So this lecture for section 12.1, and this is not MAC 302233, it's 1105 college algebra. So for number 9 here, we're going to do systems of equation, which is usually 2 equations or 3 equations with either 2 unknowns or 3 unknowns, depending on the number of equations. So for number 9, what we're trying to find is if the ordered pair 2, negative 1, sorry. So the ordered pair 2, negative 1 is a solution to this system. Now, in order for it to be a solution, it has to solve both equations. So for the first one, I get 2 times 2 minus negative 1. Does it equal 5? So 2 times 2 is 4. Now, a negative and negative 1 is a plus 1, so you can see that this is equal to 5. So this solves the first equation. Now we're going to see if it solves the second equation. Again, I have to get a true statement in both of those in order for it to solve it. So here we have 5 times 2 is 10. 2 times negative 1 is negative 2. 8 is equal to 8. So therefore, this is a solution to the system of equation that was given to us at the beginning. So the next one is number 19, and number 19, obviously we don't have an ordered pair to plug in, so we have to solve this system ourselves. So the first thing I want to do is I'm going to solve, so I'm going to name this my equation 1 and equation 2, right, just for the sake of identification here. So what I'm going to do is I'm going to leave equation 1 the way it is, and I'm going to solve equation number 2 for x. So that means that x is equal to 4 plus y, right? I just added y to both sides. Now, since x is equal to 4 plus y, I can take that information and plug it into my equation number 1, right? So this is 4 plus 2y is equal to 8. 8 minus 4 is 4, and I divide both sides by 2, and I get y is equal to 2. So now that y is equal to 2, I know that it works in equation number 1. I'm going to plug this information into equation number 2. Since I solved for x in this one, so x is going to be equal to 4 plus 2, which means x is equal to 2. So the potential solution would be 6, 2. So I know that it works in equation number 2. I'm going to make sure it works in equation number 1. So 6 plus 2 is equal to 8. 8 is equal to 8. So then the solution for this one is, in fact, the ordered pair 6, 2. So the same thing for this one. I'm going to go ahead and solve. I'm going to leave the first equation the way it is. I'm going to solve the second one for x again. It doesn't really matter. So x is equal to negative 3 minus y. So then I'm going to go back and I'm going to plug it in. So negative 3 minus y plus 2y is equal to negative 7. Right? So I plugged it in here for x. So I'm going to combine like terms. So negative 3 plus y is equal to negative 7. Y is equal to negative 7 plus 3, which is negative 4. Right, so now I got that y is equal to negative 4. Now I'm going to go back and I'm going to plug it in. The same thing I did to equation number 2. So x is equal to negative 3 minus negative 4, which is negative 3 plus 4, which is 1. So in this one, they're telling us that x is equal to 1. So the potential solution is 1, negative 4. Now I know that it works in equation number 2, so I'm going to plug it into equation number 1. So negative 4 plus 2 times 1 is equal to negative 7. So now, in this one here, I'm going to have, I plugged in the wrong values. So 1 plus 2 times negative 4 is equal to negative 7. 1 minus 8 is equal to negative 7. Negative 7 is equal to negative 7. So this is a solution. Sorry about that. So 1, negative 4 is a solution to the system equation presented in number 20. Let's go to number 22. So number 22, instead of doing substitution, which we did in the previous ones, what we're going to do is we can actually add these two equations. So I can add equation 1 to equation 2, right? And then when I do that, if I add it, x plus 2x is 3x. 3y plus negative 3y is 0. 5 plus negative 8 is negative 3, which means that x is equal to negative 1. Now I'm going to substitute this in equation number 1. So negative 1 plus 3y is equal to 5. 3y is equal to 6, and y is equal to 2. So the potential solution is negative 1, 2. So I know that it works in the first one. Now let's see if it works in the second equation. So 2 times negative 1 minus 3 times 2. So negative 2 minus 6 is equal to negative 8. That's a true statement. So then this is a solution to the system of equation that's presented in number 22. So the next one we're going to go down is to number 37. Now number 37 is a little different because we have some fractions, but I'm going to go ahead and delete this here so I have some more space just in case. So what I'm going to do for this one is I'm going to multiply equation number 1 by 6, right? So I'm going to do equation number 1 times 6. And the reason I'm going to do that is because 6 times 1/2 x is going to be 3x. Now 6 times 1/3 y is going to be 2y. And then 6 times 3 is going to be 18. I'm going to multiply equation number 2 by 12. So 12 times 1/4 is 12 times 1/4 x is 3x. And then 12 times 2 over 3 is going to be 8y. And then this one's going to be negative 12. So now that I have that, I can just subtract equation 1 from 2. So if I do 3x minus 3x is going to be 0. And then 2y minus negative 8y is going to be 10y. And then 18 minus negative 12 is 18 plus 12, which is 30. And that means that y is equal to 3. So I got y is equal to 3. What I'm going to do is I'm going to go ahead and find x, right? So I'm going to go ahead and plug it into equation number 1. So 3x plus 2 times 3 is equal to 18. 3x plus 6 is equal to 18. I'm going to subtract 6 from both sides, which I get 12, and x is equal to 4. So the potential solution is the ordered pair 4, 3. So now I know that it works in the first equation. Now I have to make sure that it works in equation number 2. So 3 times 4 minus 8 times 3 is equal to negative 12. So 12 minus 24 is equal to negative 12. So negative 12 is equal to negative 12. That's a true statement. So this is the solution to the system of equations that's presented in number 37. Now, number 43, we're going to go ahead and solve it the same way. But what we're going to do here is that we can multiply the first equation by 2. And so when I do that, it's going to get 2x minus 2y is equal to 12. And I have 2x here, minus 3z is equal to 16. And then 2y plus z is equal to 4. So now when I do that, I can eliminate x, right, by subtracting. So when I subtract that, I get 2x minus 2x, which is 0. Negative 2y minus 2y is negative 4y. And then negative 3x minus x is negative z, sorry. And then, of course, actually, let me do the first one here. So I'm going to bring down... sorry for a second here, I lost them for a moment. So multiply it by 2x. And then the next thing that I'm going to do after I do that is I'm going to add the first equation to the second equation. When I add the first equation to the second equation, this is what I get, right? So negative 2y minus 0 is negative 2y. Then 0 minus 3z is negative 3z is 3z. And then 12 minus 16 is going to be negative 4. So now my equation here is 2y minus 3z is equal to 4. Now what I can do now is I can go ahead and, since this is my new equation, I'm going to put equation number 3 here. And then what I'm going to do with that one is I'm just going to go ahead and add these, right? So negative 2y plus 2y is 0. Negative 3z plus 3z is negative 2z. Then negative 4 plus 4 is going to be 0, which means that z is equal to 0. So now that z is equal to 0, I can go back to this one here, and I can solve for y. So 2y is equal to 4, y is equal to 2. So here I have y is equal to 2, z is equal to 0. Let me go ahead and plug it into the original one. And x is equal to 6. So the solution is 6, 2, 0. And I'm going to leave 46 extra for you guys. And that's the end of 12.1. Thank you.